Right.
And you want to minimize the cost.
Mm-hmm. Okay.
But the can is cut from a square with the scraps discarded.
So okay, so you have to pay for all the material to make the lids, even though you're only using the circle that gets cut out, right? Okay.
Say that again?
So you're gonna cut the circle, the two lids, the top and the bottom. You're gonna cut those circles out of squares and then just discard the 4 little tabs that are left over. But we still have to pay for those. Those are still materials you have to pay for. So what do I need to do? Where should I start?
Well, we want to minimize costs.
Right? But what do I do? Tell me what to draw up here or right up here. What am I doing?
Well, we're cutting out of squares. We need area of squares and rectangles.
Right. Okay. So maybe I draw a picture of our cans. Okay. So there's my can. Right. We'll call this distance R. How about? What are we going to call this? Height. How about? Okay, I like it. Okay. So what's the area that we need for the 2 lids? What's that going to be? Two R squared, right? Because we're gonna cut these out of squares. Right, where that distance right there is 2R, if that's R, right? Everybody agree? Okay. So if I want to come up with a cost equation then,
So you'd have to relate that with the cost.
yeah, I am, you're right.
And so the lids are twice as much as 2K.
Okay, so the lids we're going to multiply by 2K, and there's 2 lids, times 2 times, yeah, everybody agree? Right? There's the cost per unit area, right? Times 2 lids times the area of the materials for each lid, okay? Plus, what's going to be the cost of the tube part? What's the lateral area of a cylinder? Just think if you cut it and unroll it, what is it?
It's a square, it's a rectangle.
Mm-hmm.
With side R length.
If I unroll it, what's going to be the length of that rectangle?
H.
Well, the height, okay, the height will be H, yeah.
The length is
R?
Well,
If I cut the can and unroll the whole can?
wait.
Wouldn't it be 2R?
2R?
Or R squared?
That's
That's a cross. That's ours all the way across.
this is a cylinder though, right?
The circumference.
Yeah, what's the circumference of a circle?
Oh, 2 pi.
R. Yeah, okay. And then we need H, right? Times H. Okay. All right, so then our cost ends up equaling, what is that for? So 16K R squared plus 2K pi RH. Everybody buy that? Okay, what's wrong with that? 2 variables. Okay.
The volume is 128 pounds.
Aha. Okay, what's the volume of a cylinder? Pi r squared H, right?
No, and then I go home and I do it in my
Okay, so what are we going to solve for? H, right? Because there's an H. So if we solve for h, we just get what, 128 over r squared, because the pi's will cancel. What do I do with that substitution equation? Put a box around it, because I need to use it. And then I'll make my substitution. And I come up with cost as a function of radius is 16k r squared plus, what am I going to get here? 256 pi I really shouldn't have included that pi, should I? Yeah, I'll tell you what, let's cheat a little bit just so we can get the pi's to cancel. Yeah, let's just cheat a little bit. Let's just do that. So h equals, we're going to have a pi on the bottom then, right? Everybody agree? That's a little nicer, because then when I multiply, the pi's will cancel. Okay, you guys tell me if you're good with this. So then when I multiply h up here, the pi's will cancel. I'm just going to get 256k over r. Agreed? Because I get an r squared on the bottom and an r on top. Okay, what would my domain be? Real quick, what's my domain? What's the bottom of my domain? Okay, 0 but not inclusive, right? How come I can't include 0?
Then you wouldn't have anything.
Yeah, because look, that would make the height infinite, right? And what's the upper end? If the height went to 0, what value of r, what would r have to do to make h shrink towards 0? What do you have to do to a fraction to make it approach 0?
Set the denominator equals 0. The denominator would have to be 0.
0?
It's undefined.
No. If a fraction is going to go to 0, what has to happen to the denominator?
It has to get bigger.
What's it have to do?
Top has to get infinitely big.
Well, the top, I mean, if the fraction, think how fractions behave. Like,
The bottom has to get bigger.
bottom has to get big, right?
It's like
The bottom gets big for the fraction to get small, right? Okay. So then that means that r would have to approach infinity for h to approach 0, right? Okay, this is something, I'm just going to remind you about something. Anytime you're doing a problem like this, could be optimization, could be related to rates, if your constraint is a volume constraint, volume, I mean, you can squish that volume along one dimension and it's going to spread out infinitely far, right? If there's a volume that's a finite volume, if one dimension goes to 0, some other dimension has to go to infinity, right? Because it has to squirt out somewhere. It's got to go, and it's a finite volume, right? Okay? So now what?
And now we take the first derivative.
Okay, what do I get? Okay. So 32 kr minus
256k over r. Yes.
Okay, good. And so C prime equals 0 when? It's only undefined at 0, which is not in our domain, right? When those two are equal, good. So then I would just cross multiply, right? And get 32k r cubed equals 256. Let's see, that's got to be 8. So, and there's a k there, right? So the k's cancel. R cubed would equal 8. So what's R? 2. Okay. Okay, just to justify this, though, to show that that's a minimum, second derivative is actually going to be pretty easy. You don't have to really do much with it. What is our second derivative? 32k plus, and there's the key thing. It's going to be plus some fraction involving r, right? You don't even really have to figure it out. It's going to be what? Plus 512 over k over r cubed. But wouldn't you agree that for any positive value of r, which is our domain, that's going to be positive? Right? So when we make our table is really simple. Don't resist the tables. The tables are great. There it is, right? There's our justification. So that's a minimum for cost. And if we wanted dimensions, then I just need the height. Where would I go for the height? Right there, right? Okay? Make sense? Okay? All right. Another one?
Unless you guys don't want to do another one.
I don't care. It's up to you guys.
Would you rather work our cubed in practice?
Work? Yeah. Okay. All right. There's our refresher. Have at it.